In question 25, Tom the cat is chasing Jerry the mouse across a table surface 1.5 meters above the floor. Jerry steps out of the way at the last second, and Tom slides off the edge of the table at a speed of 5 meters per second. Where will Tom strike the floor, and with what velocity components will he have just before he hits? Now, we're actually going to take an extension to this problem and figure out Tom's speed. Even though the question didn't ask for it, we're going to calculate Tom's speed right before hitting the floor too. Now, Tom and Jerry was a classic cartoon from a long time ago, so this reference and the question may escape many of you, but nonetheless, let's see how it works. This is an example of a projectile motion problem. And we know a projectile motion problem is going to occur when an object flies through the air, number one, and curves because of gravity's influence. So if gravity makes an object curve as it flies through the air, then that object is by definition a projectile. So this particular problem is a horizontally launched projectile. So let's go ahead and draw a picture of this. Here's the floor. There's the tabletop. Okay, and I'm going to draw the mouse. Okay, and the cat. And basically what happens is the mouse steps out of the way and Tom the cat does this. Woo! Right off the edge. So this pathway is going to represent Tom's motion over the edge of the table and off the floor. This is an example of a horizontally launched projectile. Now, like with all projectiles, there is horizontal motion in the x direction, and one of the things we learned is that horizontal motion, the object moves with constant velocity. Vertical motion, in other words, the reason Tom is curving to the ground, occurs because of free fall acceleration due to gravity. In constant velocity, we only list 3 variables: x, v, and t. With vertical free fall, we list 6 variables: y, y naught, v, v naught, a, which is equal to a negative g, which we plug in the number 10 for that constant acceleration due to gravity, and then t is time. The only change we made is that v in the x direction was v naught x. And the reason why, if we look at this right here, v naught x is this initial blue arrow here. Well, if all of these other arrows are v in the x direction, then v in the x direction equals v naught in the x direction. So really, as long as we account for the velocity horizontally once, it's the same for every horizontal velocity along the way. So we're going to account for v naught x. Here, we have to decide which of these is going to be the lowest point and the highest point. So since Tom lands on the ground, in this case, I'm going to call the final position of Tom 0, and I'm going to call the height of the tabletop his initial vertical position, which would be the 1.5 meters. Now, this would be Vy, which that's what we're looking for in part B. Part B, we're looking for Vy. And this would be V naught y, which is equal to 0, because if you remember, when an object is horizontally launched, it only has velocity in the x direction. It gains velocity in the y direction because gravity acts on it as it flies through the air. But initially, it only has horizontal velocity. Therefore, the vertical initial velocity of V naught y is equal to 0. Vy is a question mark, and time is a question mark. So, we want to find where will Tom strike the floor. Well, we're looking for this. This is the main part of A right there. But we need some information. So if I look back in the problem, we already listed the 1.5 is the height above the floor, but we also have 5 meters per second. Well, that's the speed he's flying off the edge of the table with. Now, we have an issue. I can't really use this equation just yet because I don't know the time. But if I come over to my list of vertical variables and I choose a good free fall equation, say the second one, then this is equal to 0, this is equal to 0, and I can solve for time. And then once I find time, I can plug it in here, and I will know exactly how far Tom flew from the edge of the table. Let's try this out and see how it works. Well, first thing I'm going to do is I'm going to rewrite, and I get 0 equals y naught minus 1/2 gt squared. I'm going to add this 1/2 gt squared term over to the left and rewrite. And I get 1/2 gt squared equals y naught. Now, in order to solve for time, I need to multiply by 2, divide by g, and then square root. And if we plug in our values, for time it takes to fall over the edge, 2 times 1.5 meters is 3 over 10. Well, 3 over 10 is a third, and if I take the square root of a third, I get approximately 0.55 seconds. So it takes approximately 0.55 seconds for Tom to fly through the air. Well, that's the same 0.55 seconds that he's going to fly horizontally as well as vertically. So now I go to this equation and I plug in my values. Those cancel, and Tom flies about 2.75 meters away. Pretty far away. Must have been going pretty fast off the edge of the table. Now, to find part B, we want to know the components of velocity. So for part B, we want to know the components of velocity. We want to know Vx and Vy. So if we were to draw a picture, Tom is going to land in this direction here, down and to the right. And if we examine the components, here's the x component, here's the y component. Now the x component, if we remember, is the same all the way throughout. It's constant. And if we remember, the x component anywhere is the same as the initial x component of velocity. Since we know the initial x component is 5, that's the same as any x component of velocity. So Vx is going to equal 5. And in Vy, we can use the equation V naught y minus gt. canceling this, we get Vy is equal to negative g times t, or negative 10 times 0.55, or negative 5.5 meters per second. This means 5.5 meters per second going downward. Now, if we were to go one step further, these are the components for velocity, so technically we're done with the problem. But if we wanted to find the speed, how fast was Tom going when he hit the floor, we now need to do this. Here was the velocity. This was Vx. And this was Vy. We need to use Pythagorean theorem. V squared, which is the speed, the hypotenuse here, is equal to Vx squared plus Vy squared. So V would be equal to the square root of 5 squared plus 5.5 squared. And let's see. Plug that in our calculator. Okay, we're going 5 squared plus 5.5 squared is 55.25. Then taking the square root of that, we roughly get about 7.4 meters per second is how fast Tom would be going when he hits the floor. But the question asked for the components of velocity, so technically we could end right there.